Interesting. I'm thinking we have some pretty clear evidence of a chemical reaction occurring. Let's see if we can get a close-up of these three reactions. So first, let's take a look at the zinc plus hydrochloric acid. Let's see if I can get this into focus. There we go. So that's the zinc. Clearly, bubbles are forming all of the zinc and even rising up into the atmosphere. So that's the zinc. Let's take a look at the aluminum. And so the piece of aluminum has actually almost disintegrated into nothing, but at the very least we can see evidence of gas production, seeing the bubbles. And the third experiment is the iron in the form of steel wool, and there you can also see some evidence of gas production. Okay, so let's see if we can make sense of these results. So, and again, our goal is to figure out what the products are of these three reactions. And we can't do the hydrogen flame test. There's just not enough bubbles being produced. But let's see what we can do nonetheless. So, determining the reactants is easy. We are the ones that are putting the stuff in the test tube and causing them to react. So we know what the reactants are. So we have aluminum, which is a solid, reacting with hydrochloric acid, which is dissolved in water, so that's an AQ. We have zinc, which is a solid, reacting with hydrochloric acid, AQ, and we have iron, which is a solid, reacting with hydrochloric acid, which is an AQ. And they all are reacting and forming products. So one of the products we know is a gas. Now this is key. So one possibility is it's a metallic gas. You can vaporize metals, but it takes a really high heat to vaporize metals. So I'm pretty sure we're not producing aluminum gas, zinc gas, or iron gas or vapor. I know we're not producing chlorine gas, and so that, because I didn't die, so that leaves us with hydrogen. So we have, quite quickly deduced that one of the products of each of these reactions must be hydrogen. And now we're in a similar situation we were when we were trying to figure out the magnesium plus hydrochloric acid reaction, the product of that. And that is, we only have two choices left. Aluminum and chlorine end up over here separate, but we know that's not the case because I didn't die due to chlorine gas poisoning. So the aluminum and chlorine must have united or bonded to form aluminum chloride. And I know that aluminum chloride is soluble in water, so that's in its aqueous state. Here is zinc chloride. I also know that zinc chloride is soluble in water, and we have iron chloride. And so, again, quite quickly, we have determined the fate of what atoms are doing in these three reactions. Remarkable. One other thing to add here, and there's no way to deduce this from any evidence in this lab, but I'll just do it for completeness. I know that the formula for aluminum chloride is not AlCl, it's actually AlCl3. The formula for zinc chloride is ZnCl2, and the formula for iron chloride is FeCl2. Again, no way to know that 3 chlorines bond with 1 aluminum, 2 chlorines bond with 1 zinc, and 2 chlorines bond with 1 iron. From this experiment, we now know that in 2021, so I'll just report that to you, and we'll actually get to that later. But for now, just for completeness, we'll make that correction for you. And but otherwise, the fact that we were able to deduce that this chlorine unites with this aluminum, this chlorine unites with this zinc, and this chlorine unites with this iron is pretty remarkable. Again, with some simple analysis, simple logic, we are deducing the fates of atoms inside of chemical reactions. Not too shabby.